Okay, number one, we're going to add f of x and h of x. So I'm taking my x squared plus 2, and I have to add to that h of x, which is x plus 4. I want to add like terms. X squared and x are not like terms, so I will have both of those still, but the 2 and the 4 together will make a 6. Then now I subtract 4x minus 3 minus x plus 4. I want to distribute that negative throughout. I'll do that in a different color so you can see what I did. Change it to addition, distribute, so the x becomes negative, the 4 becomes negative. So then if I combine the like terms, 4x and negative x makes 3x. Negative 3, negative 4 makes negative 7. Now I multiply. So x plus 4 gets multiplied by 4x minus 3. That becomes a FOIL problem. So 4x squared minus 3x plus 16x minus 12. Combine the like terms there in the middle. We have 4x squared plus 13x minus 12. Okay, f of x is x squared plus 2 over 4x minus 3. Number 5, h of g of x. So we start on the inside. G of x is 4x minus 3. So I will look at the h function, and it says x plus 4, but I won't actually put x instead. I substitute the g into that spot. It goes into the x spot. So instead of x plus 4, I have 4x minus 3 plus 4. Combine the like terms, the negative 3 and the 4. So I end up with 4x plus 1. The next one, we'll start on the inside, the g of x, 4x minus 3. I plug it into the f. So the f says to take the x and square, but I replace x with 4x minus 3. I have to square it, and then I'll add 2. To square 4x minus 3, you have to take 4x minus 3 times itself, times 4x minus 3, and then add 2. So that's a FOIL problem. So we get 16x squared minus 12x, another minus 12x, plus 9, and then at the end I have plus 2. Combine all like terms, I've got a 16x squared. Negative 12x and negative 12x make a negative 24x. And 9 and 2 make 11. Now we find the inverse. So we switch the x and the y. F of x is like a y, so I'm going to replace that with an x. X is like a y, or I switch the x to a y rather. To solve this for y now, I would subtract 1 from x. Those are not like terms, so that stays x minus 1. Divide by the negative 4. So now I got y by itself. X minus 1 over negative 4. We don't like to leave negatives in the denominator, so I'm going to put it in front of the fraction. I wouldn't count it wrong if you left it in the denominator, though. Since it was in function notation, I can go back and switch it, put it in that inverse. But once again, if you left it as a y, I would accept that also. Number 8, x equals 3y squared plus 2. First step is to subtract the 2. X minus 2 is equal to 3y squared. There is no parenthesis around 3y, so the square does not apply to the 3. You cannot square root right now. We haven't isolated the y squared. I have to get rid of the 3 next, so you have to divide by 3. So we have y squared equals x minus 2 over 3. Now to get rid of the square, I'm going to square root. So when I square root, the one side will be y. I'm going to switch sides here just so the y's on the left side. Since I'm square rooting, I have to do plus minus, and then I'll have the square root of that whole fraction of x minus 2 all over 3. I can switch it back to function notation, so f, and then do the inverse notation. So inverse of f of x is equal to plus minus the square root of x minus 2 over 3. We could fix the denominator like we've learned now. We hadn't learned that yet. Oh, we did maybe square roots, but we hadn't done a lot of it yet when we learned this problem, so we just left it as a fraction. I would leave that okay. If you decided to multiply both top and bottom by a square root of 3 to fix that, that's fine too. That's even better. Okay, number 9. I'm going to isolate the square root, so I have to add this 1 that's at the end. So 3 equals the square root of x minus 1. To get rid of the square root, I would square both sides. So 9 equals x minus 1, add the 1, and I get x equals 10. The next one, I'm ready to square both sides, because an exponent of 1/2 is really a square root. Square both sides, you're left with 20 minus x equals, and 4 squared is 16. So then I would subtract 20 from both sides. Negative x equals negative 4, so x has to be positive 4. Number 11, square both sides. Takes out both square roots at the same time, so 3x minus 11 has to equal 5 minus x. And then we would solve. I'm going to add x to both sides. I'll add 11 to both sides. So we get 4x equals 16. So x is equal to 4. On the back page, it's wise to recognize the h and the k. H, we have to switch signs, so it's a negative 2. K is the 3. So when I make my table of values, we start with the h and the k. So negative 2, 3. If you're not sure what to plug in, if you don't remember, then you can always plug it in the graphing calculator. Type, you have to go to the y equals, I already went there. Then type in that equation, square root of x plus 2. Now since I'm done with the square root, arrow to the right to get out of the square root, then put plus 3. Now if we go to the table, it's in blue, so second. I can scroll up until I see errors. Oh look, and you can't see that real clearly because it's not zoomed in that much, but at negative 3 there's an error, but when I get to negative 2 we get an answer finally. So negative 2, 3, and that's the order pair I started with. And so then let's grab some nice ones. So negative 1, 4 is a nice one. There's another one at 3, 5. I'm going to go down until I find one more. A lot of times we've been doing 4, 7, 6. Let's plot those points. Okay, yeah, I think I got that all. Okay, so connect the dots. Remember, negative 2, 3, that's the beginning of the problem. So don't go through there, don't put an arrow. It does say up here in the instructions, give the domain and the range. So the domain, x is anything greater than or equal to that initial value, the h, the negative 2. Y, it's going up, so it's greater than or equal to the k, which is 3. Number 13 rather, sorry. H, there isn't a number inside the square, so it's a 0. K is a negative 4. So I know already that my ordered pairs are going to start with 0, negative 4. But then I could go ahead, type this equation in as well. So go to y equals, clear the one that was already there. Negative 3, use the negative to start with, not the minus. It will give you an error. Negative 3 square root of x. I'm done with the x now. Get out of the square root. Minus 4. Now you have to hit minus, not negative. That would mess it up as well. Okay, I'm going to go to table, second table. I see errors until I get to 0, -4. I already knew 0, -4. The next one is 1, -7. Then 4, -10. Now if I keep going, I can go to 9, -13, but -13 doesn't fit on my graph, so I'm not even going to bother with that one this time. Okay, let's put those points on here. And it would be off the graph after that. So it starts to flatten out as it goes. For the domain and the range, the domain can be anything, x can be anything greater than or equal to my initial value, the h value, the 0. The range, this time it's going down. I can see it in the picture, and I have a -a value. That tells me it's going to be less than or equal to, since it's going down, whatever the k value is, which is -4. Number 14, the fourth root of 216. 16 is actually 6 times 36. 2, 3, 6, 6, a bunch of 2's and 3's. Really, I mean, I can rewrite it. Fourth root of, I've got 2 to the third, and I have 3 to the third. I'm looking for 4 of a kinds. There's no 4 of a kinds. Similarly, if I wrote this as fraction, this would be 2 to the 3/4. That doesn't simplify. 3 to the 3/4. 3/4 doesn't simplify. There's actually nothing to do in this problem. It doesn't simplify. Since it doesn't simplify, it all stays in the fourth root. Multiply it back together, it's 216. It was the original problem. Okay? It wasn't the nicest problem to give because it doesn't actually simplify. So I should have given a better number. I can assure you on the test, I would give you one that will actually do something. So you probably won't get a problem quite like this. Something will happen. So go ahead and break it down and see what you can do. Number 15, I'm looking for 5 of a kind. It's a fifth root. Well, there's 5 a's, and there's actually 11. So I could pull 5 a's out once and twice, because there's 11 of them. So I pull a out twice, so that's a to the 10th. Inside, there would still be 1 left, because there was 11, 5 goes in there twice, that would be 10, there's a remainder of 1. So this a, it's going to stay, and it's still a fifth root, so keep the 5 there, but there's going to be a leftover a inside there. As for b's, there's 15 of them, so I can pull b out 3 times with nothing remaining. So my answer is a squared b to the third times the fifth root of a. Number 16, multiplied, there's a 2 out front. There's no other number out front, so just a 2 out there. Then inside the square root, I'll have 32 times 8. That's going to be a 256. When I multiply that together, then combine the x's. So I've got 3 of them and 7 of them, and it makes a total of 10. Then for the y's, I've got 5 and 2, so that makes a total of 7. So I want to see what I can pull out now. Now on 256, I can break that down. I'm going to break it into 32 and 8. 4 and 8. 2, 2. 2, 4. 2, 2. 2, 4. 2, 2. We get lots of 2's. So I have a pair, a second pair, a third pair. Oops, sorry, there was a third pair right there. And then a fourth pair. So it was actually 2 to the 8th power. But I got to pull out 2 4 times. 2 times 2 times 2 times 2 is 16. There's already a 2 out front. So there was a 2 out front. I just pulled out 16 from all of those 2's. And then as far as x's go, I had 10 of them. It's a square root, so I'm looking for pairs. So I can pull x out 5 times. And then as for y's, I have 7 of them, so I could pull y out 3 times, y to the third, but there's a leftover y that stays inside the square root. So all I can do now is go ahead and finish my 2 times 16, so I have a total of 32 out front. 32x to the fifth, y to the third, times the square root of y. Oh, sorry. Number 17. I'm going to factor tree the square root of 12, square root of 32, and square root of 72. Since this is not a multiplication problem, I have to do this. I can't add or subtract unless the square roots are the same. And they're not. 12, 32, and 72 are different numbers. So let's see what we can do this way. So on the first one, I get a pair of 2, so I get to pull out a 2. There's already a 9 there, don't forget. So pull out a 2, 9 times 2 is an 18. And I'm left with a 3 inside the square root. The next one, 4 times 8. So I have a pair of 2s, a second pair of 2s, and then a 2 left over. There's already a 5 out front. Pull out 2 times 2, which is 4, times the 5 that's already there. It is plus, so we've got a 20. Inside is a 2, so 20 squared of 2. On 72, I can do 2 times 36. 36 goes to 6 and 6. I get 2 and 3. 2 and 3. So a pair of 2s. A pair of 3s with a 2 left over. It is minus. There was no number in front this time, so I pull out a 2 and a 3, which multiplies to make 6. Inside there's a 2 left over. So I have 18 squared of 3 plus 20 squared of 2 minus 6 squared of 2. Now, can I combine like terms? Well, I can. There are 2 square roots of 2. The square root of 3 doesn't combine with them, so I still have 18 squared of 3. But then 20 squared of 2 minus 6 squared of 2, 20 minus 6 is 14, so it's 14 square roots of 2. So 18 square roots of 3 plus 14 square roots of 2 is our answer. Number 18, x to the negative 1/2. If I have a negative exponent, that power goes to the denominator. But I can't leave an exponent that's a fraction inside the denominator. So I have 1/2 down there. I'd like 2 halves, so I need to bring in another 1/2. So I multiply both top and bottom by x to the 1/2. My numerator, 1 times x to the 1/2, is just x to the 1/2. My denominator, 1/2 times 1/2, 1/2 and 1/2 makes 2 halves or 1, so it's just x to the 1, or just x. So my answer to the problem is x to the 1/2 over x. 19, I have a multiplication problem, so I will add these exponents together. Keep the base number of x, add 1/3 and 2/5, but I need a common denominator, which would be a denominator of 15. So 1/3 turns into 5/15. 2/5 turns into 6/15. Add those together, I get 11/15. That's my exponent, so I have x to the 11/15. Number 20. It's a 4th root. 8 goes to 2, 2, so at 2 to the 3rd, so I'll get to pull out a 2. With no number left inside there. A to the 6th, so I get to pull out a twice. B to the 12th, so I get to pull out b 4 times. I don't get to pull out any c's. There's 2 of them, and it takes 3 to come out. So I'll still have the c squared inside of a cube root. Alright, and that concludes the video.